Use cylindrical shells to find the volume of the solid obtained by rotating the region bounded by the graphs of y equals x graphed in red, y equals 7 minus x graphed in blue, and the x-axis graphed in green when rotated about the x-axis. The boundary region R is this triangular region. And we have rotation about the x-axis. Notice the point of intersection at the top is 3.5, 3.5. To determine this algebraically, we would have to solve the system of equations y equals x and y equals 7 minus x. Let's quickly show this. To solve the system, let's substitute y for x in the second equation, which gives us y equals 7 minus y. Solving for y, we have 2y equals 7, dividing both sides by 2. We have y equals 7 halves, or 3.5. And because y equals x, we have the point 3.5, 3.5. And now let's take a look at this in 3 dimensions. On the left, we have the boundary region R graphed in 3D. And if we rotate this area about the x-axis, we obtain the solid shown here on the right. Our goal is to use the shell method to determine the volume of this solid. Whenever using the shell method to determine volume of revolution, we always want to sketch a representative rectangle that represents one tuber shell of volume when rotated about the x-axis. When using the shell method, the representative rectangle will always be parallel to the axis of rotation. When using the washer or disk method, the representative rectangle will be perpendicular to the axis of rotation. So let's use this as a representative rectangle, where if we rotated this about the x-axis, we would have one shell or one tube of volume of the solid. Notice the thickness of the rectangle is delta y, which indicates when we have a horizontal axis of rotation, we integrate with respect to y. The volume is equal to 2 pi times the integral from c to d of r of y times h of y dy, where r of y is the distance from the center of the rectangle to the axis of rotation, which in our case would be this distance here. Notice this vertical distance is simply equal to y. H of y is the height of the rectangle, which again for our rectangle is this horizontal distance here. Again, h of y is the height of the rectangle, but it must be a function of y. Notice the height of the rectangle is determined by the horizontal length between the two lines. To determine h of y, we'll first have to determine the distance from the y-axis to the blue line, this distance here, and then subtract the distance from the y-axis to the red line, again as functions of y. So let's call the green distance x sub 1 and the blue distance x sub 2. Notice the distance x sub 1 is determined by the blue line given by the equation y equals 7 minus x. So beginning with y equals 7 minus x, we need to solve for x by adding x to both sides and subtracting y from both sides, which gives us x equals 7 minus y. And this is x1 on our graph. x2 is the distance from the y-axis to the red line, which is given by the equation y equals x. And since y equals x, x2 is equal to y, which indicates h of y, again, is equal to x1 minus x2, or the quantity 7 minus y, which gives us 7 minus 2y for h of y. Now that we have r of y, the distance from the center of the rectangle to the axis of rotation, and h of y, which is the height of the rectangle, both as functions of y, we can now set up the integral that will give us the volume of the solid when the region R is rotated about the x-axis. The volume V is equal to 2 pi times the integral. We're integrating with respect to y, and therefore the limits of integration for y are from y equals 0 to y equals 3.5. which is why we needed to determine the point of intersection 3.5 comma 3.5. Now the integrand function again is r of y times h of y, where r of y is y, times h of y, which is the quantity 7 minus 2y dy. Let's rewrite the integrand function. Let's also write 3.5 as 7 halves. The integrand function is 7y minus 2y squared. Next, we determine the antiderivative, and don't forget about the factor of 2 pi. Integrating 7y minus 2y squared, we have 7 times y squared divided by 2, or 7 halves y squared, minus 2 times y cubed divided by 3, or minus 2/3 y cubed. Next, we determine the product of 2 pi and the difference of big F of 7 halves and big F of 0. Big F of 7 halves is equal to 7 halves times the square of 7 halves minus 2/3 times the cube of 7 halves minus big F of 0 is equal to 0. Simplifying, we have 2 pi times the difference of 343/8 and 343/12, which is equal to 2 pi times 343/24, and 2 pi times 343/24 equals 343/12 pi, and because this is volume, the units are cubic units. This is the exact volume of the solid when the bounded region R is rotated about the x-axis, which again would be the volume of this solid here on the right. I hope you found this helpful.